Hello, ladies and gentlemen. Mr. Klein coming at you here from Bloomfield Studios in the heart of the G-Wing. This is inverse trigonometry. Got my little setup going. I haven't made one of these videos in a long time. We'll see if I've still got it. I don't love the lighting situation around here. It's kind of blackened out my face and left me with this weird light glow across my hairless head. All right, let's do it. Which of the following angles have a sine ratio that is equal to roots of 2 over 2? I'd like you to pause the video and figure out which of these angles. And the answer is every single one of these angles has a sine ratio equal to roots of 2 over 2. Pi over 4 is this. Whoop. 3 pi over 4 is this. Woo. 9 pi over 4 is go all the way around and a little bit more. Bing, 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 bing. Negative 5 pi over 4 is back it up, back it up, back it up, back it up, back it up to here. And negative 7 pi over 4 is, you guessed it, back it up just a little bit further until you get to there. So the moral of the story, every single one of these angles has the same sine ratio of roots of 2 over 2, which beckons the question, what do we do when we're asked this? Inverse sine of roots of 2 over 2. Well, we know that inverse sine, you start with a ratio, and the answer has to be an angle. But which angle? Do we say pi over 4? Do we say 3 pi over 4? Do we say 9 pi over 4? Do we say one of these two negative angles? They all have the same sine ratio, right? Well, what mathematicians have decided to do, and they decided this a long, long time before you and me, is this. They said that since a function can only have one output, right? Only one angle can pop out. What we're going to do for sine is we're going to say, take the angle that is on the branch, on the right side of the unit circle. Specifically, the branch that starts at negative pi over 2 and ends at pi over 2. Therefore, the answer would be this one right here, pi over 4. Now, is this kind of arbitrary? Yeah, it's arbitrary. I mean, they chose it because this seems like the simplest branch, but they could have chosen anything, right? So anytime you have a inverse sine, the output is going to be between negative pi over 2 and pi over 2. Okay. Now let's talk about cosine. Wouldn't it be nice if we could do the same thing for cosine and use the right branch? Well, math is never that simple. We can't. And the reason is that the cosine of an angle right here and the cosine of an angle right here are the same. They have the same positive x value. So we can't use quadrants 1 and 4. Instead, for cosine, we use the top half of the circle. So the positives here and the negatives here. Meaning that for cosines, your outputs will start at an angle of 0 and end at an angle of pi. So this is what you do for inverse sine. This is what you do for inverse cosine. I'm going to tell you the rest of them. Tangent uses the same principal branch as sine, as does the reciprocal of sine. And then for cosine, cotangent and inverse secant use the same branch. Once you got that written down, flip to the next page and let's do some problems with this. So for today, what I want you to be able to do, and what is technically not a calculus skill, but a skill that we will go on to use in calculus, is to evaluate these inverse trig functions. And so let's just go through an example. This says arc cosine of negative 1/2. First thing is recall that arc cosine means the exact same thing as inverse cosine. So you would begin by saying inverse cosine. That is defined in quadrants 1 and 2. So I'm going to cross off 3 and 4. I know the answer can't be there. Second, we're going to say the ratio is negative, which means that it must be in quadrant 2 because that's where the cosines or the x values are negative. Okay? And then our next step is going to be if the cosine is negative 1/2, that means that this must be roots of 3 over 2. This must be the 60-degree angle, which means this is going to be one of the pi over 3's. Specifically, it is 2 pi over 3. There's our answer. Let's do another one. Inverse sine of negative 1/2. Step 1. Inverse sine is defined on the right. So cross off quadrants 2 and 3. Second step. Negative 1/2 would be in the fourth quadrant because the signs are negative down here. Cross off quadrant 1. This time, it's the y value that will be 1/2. So that's 1/2, which means that the angle across from it is going to be the 30-degree angle. Now, I can think of two different radian angles that land right there. One of them is 11 pi over 6. The other one is negative pi over 6. Question, which one of those angles do we write as our answer? Answer, take a look at how the principal branch for inverse sine is defined. It goes from negative pi over 2 to pi over 2, which means we have to choose, of the two angles that I gave you, the one that lands in here, which would be the negative pi over 6. Hey, so be really careful when you're in quadrant 4. You're going to be tempted to use the positive angle that you get when you wrap around the circle this way, but it will not be correct for these inverse trig problems. Okay, moving along. Next one. Arctangent of roots of 3. Step 1. Where is arctangent defined? That was on the right side. So cross off 2 and 3. Step 2. Where would the tangent be positive, in quadrant 1 or quadrant 4? Well, we know that tangent is the y value divided by the x value. So for this to be a positive number, y and x would have to have the same sign, which means we can cross off quadrant 4 and look at quadrant 1. Next thing that I like to think about when I'm doing a tangent is the fact that there's only 3 options here, right? There's 60, 45, and 30 degrees. If it was 45 degrees and we had that 45, 45, 90 right triangle, then y over x would be 1. So it's not 45. It's got to be 60 or 30. Since this right here is bigger than 1, I'm confident that it's going to have to be the 60-degree angle. Look, if we choose the 60-degree angle, then this would be roots of 3 over 2. This would be 1/2. And notice that then y over x would be roots of 3 divided by 2 divided by 1/2. And if you multiply by 2 here and 2 here, sure enough, you get roots of 3. So our answer is going to be this 60-degree angle. And the 60-degree angle is equivalent to pi over 3. Moving along to number 4. Arc secant, inverse secant. We hate secant. Secant's confusing. So what I would encourage you to do is to change it into its reciprocal function. Change it into cosine. And you would do that by flipping the ratio. Cosine and secant, they have reciprocal ratios from each other. So what we would write right here would be 1 over negative roots of 2. which it's worth noting, if we rationalize the denominator, is negative roots of 2 over 2. So this one has one additional step to it, and that's that you need to start by changing to arc cosine. Now that we're here, next thing we're going to do is say cosine, top half. Negative means second quadrant. In the second quadrant, we know that the x value is roots of 2 over 2. Therefore, this is a 45-degree angle, meaning that we're going to get one of the pi over 4s. This one is 3 pi over 4. Okay, so there's your answer. 2 more. Take a look at 5 and 6. 5 is kind of an interesting one because it's got 2 steps. Start by evaluating the inside first. Inside says the cosine of 3 pi over 4. Cosine of 3 pi over 4 is equal to negative roots of 2 over 2. So we would write cosine inverse of negative roots of 2 over 2. Oh, but I just did this one, didn't I? Didn't I? That's what we did right here. We found that cosine or inverse cosine of negative roots of 2 over 2 is 3 pi over 4. Oh, which means the inverse cosine and the cosine, they sort of just canceled each other, didn't they? Okay, they canceled each other out. We just got that angle. So by that logic, wouldn't the answer to this one be 5 pi over 3? Yes, yes. Well, it's not. Check this out. Cosine of 5 pi over 3 would be, let's see, 5 pi over 3 is right here. So this is a 60-degree angle. The cosine right there would be 1/2. So this is equal to the inverse cosine of 1/2. But inverse cosine of 1/2 is only defined up here. And that's a positive angle, so I can cross off number 2. And so this angle that has an x value of 1/2 would be 60 degrees, or in other words, pi over 3. So the question is, here, why did the inverse cosine and the cosine just cancel? But here they did not. And the answer is, in the first case, this was in the principal branch of cosine that goes from 0 to pi. Whereas here, this was not in the principal branch from 0 to pi. So in order to get that cancellation between the inverse cosine and the cosine, the angle has to be in the principal branch. All right, I am going to be quiet for a minute. I would like you to try number 7, 8, 9, 10 on your own. Pause the video, and then when you're done, come back and check your work. Hey, let's check our work. The answer to the first one is negative pi over 3. If you said 5 pi over 3, you're forgetting that the principal branch of the inverse sign goes from negative pi over 2 to pi over 2. So that's what our answer should be. Number 8, the answer is 3 pi over 4. The reason is that the sine of 2 pi or 3 pi over 2 is equal to negative 1. And then the arc cotangent of negative 1 would be up top. And in the second quadrant, because this is saying x over y is a negative 1, which means that it must be this angle right here where y is positive and x is negative, but they have the same size. Okay, so that would be at 3 pi over 4 since this is 45 degrees. Moving along, we know that the sine of 4 pi over 3 is negative 3 over 2. And just like we worked out right here, the inverse sign of negative roots of 3 over 2 is equal to negative pi over 3. So this has the same answer as this one because, in a sense, they're the same problem. Last one, you see the inverse cosecant. You change it to inverse sine. 1/2 would be in the first quadrant, pi over 6. All right, that's the game.